Okay, for me it is evening time. For you guys, it is presumably morning when you're looking at this. I'm making a recording of the lesson so you can watch it when you like. Maybe you're watching it in the evening too. Alexa, turn off guest room light. So maybe that's a little bit better. Most of what we're going to be doing today is going to be right here on these pieces of paper. It is on the notes that we handed out, starting with page 14. This is all about section 1.2. Okay, for a classification of an acute angle, it has a measurement which is somewhere between 0 degrees, not including 0 degrees. So I'm going to do a roundy parentheses there, and also less than 90 degrees. For those of you who are unfamiliar with this, it is the same thing as really saying that 0 is greater, or 0 is less than x, which is less than 90 degrees. An example would be something like 43 degrees. That is an acute angle. A right angle is specifically 90 degrees. It must be 90 degrees to be a right angle. The only example would be that it is 90 degrees. An obtuse angle is one which is greater than 90, so it does not include 90. I put the curvy brackets there, and goes up to but does not include 180. For example, 100 degrees would be an obtuse angle. And finally, a straight angle isn't really an angle if you ask me. It is a line, but so it goes. It is a 180 degree and only 180 degrees. So we're going to put it's equal to it by putting those brackets. And the only example is that it must be 180 degrees. Okay, tick marks. Tick marks are useful in diagrams to show that two things are congruent. Congruent is a fancy way of saying that they have the same measure. We don't like to say that two things are equal. Two walls might be congruent. They might be the same length, they might be the same height, they might be the same size and all that, but one might just be a nicer wall. Hey, it's warmer over here, it's colder over here. This one has a better view. So they're not equal, but they are equal in one attribute called measure, and that makes them congruent. A tick mark shows me that two things are congruent. So the line segment AB I know to be congruent to the line segment EF. Does not make any sense to say that either rays or lines are congruent, but line segments may be because they have measure, and so do angles. These two angles are congruent because they are marked as such. If angles have the, and in both cases, it should be same measure or measurement. I wrote measure, it is shorter. Then they are congruent. Same thing over here. What congruent means. Like an equal sign with a little bit more. I don't know if that's visible on mine. It should be definitely visible on yours, but there it is, nice and big, like an equal sign and something more. Okay, so this time we are given that the big angle, the angle ABC, is a right angle. It is comprised of these two smaller angles, angle 1 and angle 2. And since it itself is a right angle, they have to add up to 90. The formula, which is implied here, is 5x plus 1 plus 4x minus 10 is equal to 90. I'm writing nice and big because sometimes it's hard to see on the saved Zoom chats, but kind of ran out of room. The parentheses in this case look nice, but don't actually do anything. They're like Mr. Greer in the math office that way. So I'm going to write it without the parentheses. In fact, I'm going to gather up those like terms. I have 5x and 4x. Together I have 9x. I'm adding 1 but subtracting 10. That is like subtracting 9. equals that 90. Depending on whose math class you had last year, they probably say, oh, well, you should add 9 and then divide both sides by 9. In this particular case, I could do it either way. I could divide by 9 first and get x minus 1 equals 10, and then add 1 to both sides and get x equals 11. Or the normal way is to say that 9x equals 99 when I add 9 to both sides and divide, so I get x equals 11. At this point, do not go to the refrigerator and get out a celebratory Mountain Dew or Coke or whatever your celebration beverage is of choice, because we're not done. We found what x is, but they asked me to find what angle 1 is, so I can plug it back in and say measure of angle 1 equals 5 times 11 plus 1, 55 plus 1 equals 56 degrees, and there you have it. They tell me in part 2 that angle B is acute, which only tells me that it is between 0 and 90. Restrictions on B, so 0 is less than the measure of angle B. I realize that looks like a less than sign itself, which is less than 90. To find what the restrictions are on x, I'm going to substitute in the expression for x. 0 is less than 4x plus 16, which is less than 90. I'm going to subtract 16 from all 3 sides of the compound inequality. So negative 16 is less than 4x is less than, I think that would be 74. Does that sound right? Yes, so, which is a little bit weird because that one's not divisible by 4. Just double checking here that that seems to be correct. Okay, and then dividing by 4, I get that negative 4 is less than x is less than, and let's see, 80 would be 20, so 76 would be 19, and this seems to be 18 and a half, if you're okay with the wacky way in which I do that. All right, is it okay that x itself is negative 4? Sure, there's no angle who has a measure of x. They have a measure of 4x plus 16, so that is okay. Moving on, these are a little bit of the, dare I say, fun variety. Apparently, when they redid this packet, they did not make these clocks any better. That dot does not appear to be anywhere near the center of this thing, but so it goes. Find the angle between the hands of a clock at 8 o'clock. Well, at the hour, the big hand is pointing at the 12, and at 8 o'clock, the small hand is pointing towards the 8. Hello, small child. There are 360 degrees in a full circle. We are going to divide that by 12 to, oh, might be pausing here. One sec. Sorry about that. Baby and Dorito related trauma. I don't know. So we're saying that there are 12 numbers around the clock for 360 degrees. 360 divided by 12 is 30. So to go from 8 to 9 is 30 degrees. There's 60. There's 90 as in a right angle. And we have 120 degrees here. That was easy. And that was warm up. At 8:20, the minute hand points to the 4. But at 8:20, the hour hand does not point at the 8. It points 20/60ths, better known as 1/3, of the way between the 8 and the 9. Well, that's kind of convenient because we said that there is 30 degrees between each number, and if it's 1/3 of the way, then it is 10 degrees in there. So we've got 10 degrees plus a 30, another 30, another 30, another 30. If I count those up, I've got 1, 2, 3, 4 30s plus 10 degrees. That is 4 times 30, 120, plus another 10 degrees, brings us to 130 degrees. Of course, it gets even more complicated from here when we go to 1142. At 1142, the minute hand is 2/5 of the way from here to there. And at 1142, the hour hand is 42/60, or 7/10 of the way from here to there. 7/10 of 30 degrees should be 21 degrees, if I'm doing that right. And I guess there are 3/5 of the 30 degrees here. 1/5 would be 6 degrees, so 3/5 should be 18. And I've got 30 degrees between the full numbers. So it looks like I've got 21 plus 18, we're at 39, 69, and 99 degrees, if I am doing this correctly, which it's entirely possible that I've made a mistake in here. Please feel free to check my work. Okay, the last page, and I know that we're moving kind of quick through some new material, involves degrees, minutes, and seconds. We know that angles are usually measured in degrees, but then they break down from there. A 60th of a degree goes by the same name that a 60th of an hour does, which is a minute. And a 60th of a minute goes by the same name that a 60th of a minute goes by in terms of clocks, and that is a second. So 3/4 of an hour has the same name as 3/4 of a degree. 3/4 of an hour is 45 minutes. This is 35 degrees and 45 minutes. Okay, there is, of course, another way of doing that. If you didn't immediately recognize the relationship between 3/4 and 45 minutes, 3/4 of an hour being 45 minutes, we could say that, and I'm going to write up at the top here, nice and big, 3:4, as the number of minutes I'm looking for is 260. I do these problems a little bit strangely. You may do it by cross multiplication. Multiply both sides and I get 3 times 60, 180 equals 4x. To divide by 4, I divide by 2 twice. Half of 180 is 90 and half of that is 45. Ooh, that's the number we got. But as I mentioned, I do it a little bit strangely. I usually ask, well, what do I have to multiply 4 by to make it into 60? 4 times what equals 60, or 60 divided by 4 equals, and that turns out to be 15. So if I had to multiply this by 15 to get there, I have to multiply this by 15 to get there. 3 times 15 is still that 45. Okay, so 57 degrees, 57 full degrees, and 5/12 of a degree. I'm going to give it the same treatment. Maybe I'll go down here at the bottom. 5/12 is how many 60ths? To go from 12 to 60, I multiply by 5. So to go from 5 to x, I multiply by 5. 5 times 5 is 25. This is 25 minutes. And hopefully that seems to ring true. We know that 6/12 would be half of a degree, or half of a degree. Oh yeah, half of 60 is 30, and this is a little bit less. Okay, 3/8 for that last one. So 3 is to 8 as x is to 60. I'm going to do the cross multiplication this time, and I'm going to get 180 equals 8x. My trick for dividing by 8 is just to divide by 2 3 times. Half of 180 is 90, half of 90 is 45, and half of 45 is 22.5. 14 degrees, 22.5 minutes. Oh, wait a second. 0.5 minutes? What do we call half a minute? We call it 14 degrees, 22 minutes, and 30 seconds. Okay, next up, sorry for the video of my cat washing itself. Next up, we're going backwards on that one. So this is really 7 degrees and 24 sixtieths, also of a degree. All I have to do is reduce 24 sixtieths. Well, that should be 2/5. So 7 and 2/5 of a degree is my answer. If you prefer it as a decimal, easy enough to convert, 7.4 degrees. Same idea over here, although yet another step. So this is really 23 degrees and 6 and 40 sixtieths of a minute. Okay, 40 sixtieths is 2/3. So this is going to be 23, not going to write degrees yet. And I'm going to say 6 and 2/3 sixtieths, all of degrees. That I can convert into complete and total degrees. That seems like a little bit of a pain, I do have to admit. And so to get rid of these thirds here, I'm going to switch everything into 180ths. It's a little jammed up in there. I imagine it's hard to see. I'm going to turn over this page. So we had 23 and 6 and 2/3 over 60. I'm going to multiply the top and the bottom of this by 3, which is a legal move. That is 23. 6 times 3 is 18, plus another 2 is 21 eightieths. And of course, that can reduce a little bit to 23 and 1/9 of a degree. 15 seconds, excuse me, you might recognize as being 1/4 of a minute, either in terms of time or degrees. So this is really 86 degrees, 5.25, 5 and 1/4, however you want to think of it, minutes. I put in a decimal there, which doesn't really belong there, sorry. And so it is 86 and 5 and 1/4 sixtieths. Again, I'm going to multiply the top and the bottom of this by 4. You can see what I was doing there. I'll do it nice and big over here. 86 and 5 and 1/4 sixtieths. I'm going to multiply the top and the bottom by 4 over here. I got 86 full degrees. I've got 21 over 60 times 4. I'm thinking I don't really want to do it this way, but that's okay. 240ths. This is divisible by 3, the 21. That is divisible by 3. I can say that it is 86 and 7/80ths of a degree. Okay. Addition and subtraction work the way you would think they would. You just have to be a little bit on the sneaky side with your borrowing or carrying over. Because it doesn't carry over at 100 or at 10, it carries over at 60. So lots of different ways of doing this. Sometimes people hate it when I don't tell them the way and give them the options. But I think that that's what makes a better mathematician, knowing that there are different options here and it's really your choice. I'm going to add the seconds to the seconds, the minutes to the minutes, and the degrees to the degrees here. That is like 60 minus 1 plus 47. That seems like 107 minus 1. That should be 106 seconds. Over here, it looks like I've got 57 minutes. And over here, it looks like I've got 70, 82 degrees. Well, the only problem is nobody says 106 seconds. They say 1 minute and 46 seconds. So I am going to carry that over and say 58 minutes and 46 seconds. So that is one possible way of doing this. Another way would be to carry over as soon as I hit that 60. Looks like my next one is a subtraction. Again, it works like you would hope subtraction is, but you have to really think about what it means to borrow. When I borrow a minute here, so that becomes a 12, 1 minute is 60 seconds, so I end up with 87 of them, and now I can subtract. I'll end up with, looks like 55 of those seconds. Again, I need to borrow, that becomes an 83. This doesn't become 112, it becomes a 72 because I added 60 to that 12. 66 and 26, I believe. And now when I subtract, I'm gonna end up with, what am I doing? 76 and 66. And there you go. Hope that made some degree of sense. Pun not necessarily intended there. Multiplying down here, so I'm kind of skipping that one or leaving it to you guys. Multiplying or dividing, you just really do the same thing. One of my two methods involves me just saying, oh, well, I have 50 degrees and I've got 84 minutes and I've got 60 seconds. And then saying, wait, 60 seconds? Never mind. I've really got 85 minutes and 50 degrees. Oh, wait, 85 seconds. How about 51 degrees? 60 of these seconds make that, 60 of these minutes make that degree. So subtract 60 and I have 25. And that is a correct way of doing it. The other way, again, just kind of doing it as you go. 30 times 2 is 60. Okay, carry that one over. Hi, I think that pretty much will do it. If you like, of course, please try these other degrees, minutes, and seconds, but I want to leave some for you. I left a subtraction and I guess 2 divisions, or maybe a division and a multiplying if you're multiplying by 1/2, but multiplication and division are the same thing in my mind. Okay, thanks. Let me know if you have any questions.